I would now invite Yamamoto-san, to give his perspective, on the topic that we are talking about today.
Good afternoon. Normally, so I should say good morning, but so it's late. Good afternoon for all. So I'm going to explain one of the development example using a simulation and a testing for electric vehicle thermal management system. This is purely an Indian-oriented development done by Indian staff. Okay, this is one of the keynote I took today. So what is a system we are developing? This is a electric vehicle thermal management system. We call it the EBTMS. So this system serving for HVAC. HVAC is an air conditioning system in the vehicle, and also a battery thermal management system using an active liquid. This supported by two subsystems. One is a coolant recirculation system, and also the other one is a vapor compression refrigeration subsystem. This is in fact consuming a main part of the system. There was a electric pump example in the previous presentation. More than 100 times power consumption for this system using an electric compressor. So finally, this system emits heat to the ambient air, right side you can see, through the CRFM system using a condenser. Okay, so let's focus on the main power consumption subsystem. Vapor compression system. So you can look at the pH diagram, pressure enthalpy diagram, bottom right side. Yeah, you can see the red letter compressor. Compressor compressing a refrigerant, getting a higher pressure, higher temperature. So giving a heat to the heating system using a water condenser. Then rest of the heat emitting to the environment using a condenser. Okay. Then expand the refrigerant, and getting a cool refrigerant to cool down battery and the cabin air using a chiller and evaporator. This is a cycle of the major power consumption. This is a really power consumption area. If you use a AC system, not only just a AC system, you can consume the more than 20%, sometimes 30%, sometimes 50% energy from the EV. So you can understand how important. A feature is, as you can see, so there is less energy consumption. And the benefit is, there are several benefits, but one of the most important is energy consumption, 24% less compared to the conventional system. So how to develop using a simulation and testing? This is, I just explained one example. Maybe it's too technical some of the people. Yes, this is a design process using a simulation and the testing for this kind of system, starting from a concept to the design system, algorithm, and also kinematics. Okay, blue box is a simulation associated with the design process, and the pink box is testing to validate and to optimize the system. Yeah, let's focus on some small area, but a big impact thermal system simulation and supported testing in the next slide. So this is one example showing compressor energy efficiency color mapping. Red one is a good area, blue one is a bad area. So there is a gradation on it. So because the compressor is a major power consumption in the system, based on the efficiency optimization, we need to design the system operation. So vertical axis is a compression ratio. Horizontal axis shows a mass flow rate. So mass flow rate of higher, right side, you can imagine the higher condition. Left side showing the very low thermal condition. Yeah. So if you look at the white, so this is try to use the most efficient area. Okay. So this is a simulation we are going to use. So using this system, you can avoid a non-efficient area surrounded by blue dotted circle. So more than 50 tests we can save using this simulation. Okay, next one is how to optimize in the testing. If you start the testing from the middle point, sometimes you have a fluctuation in the white dotted one. We need to converge this fluctuation to the optimized white line. This is how we are going to use this simulation linked to the testing. So if I summarize what I showed, yeah, in fact, thermal system in EV is the biggest power consumption area. So system simulation, systematically way is very, very important. Without, you don't know so if it is optimal or not. And there are several different thermal systems in this big system. You need to have we have an interrelated link. So dynamic thermal system simulation, this is we need to develop to reduce testing time. So then finally, so we need to, energy efficient thermal management system. We need to systematically build up the test cases, to reduce development time and the cost, and to recognize this system is the most efficient. Okay. Thank you very much for your attention. So I took too much time. Sorry.